Hello. Hi, everyone. I am Nikunj, co-founder and CEO at True Foundry. And today we have with us Denise, who is head of machine learning at Voiceflow, which is a conversational AI startup. And Denise, I welcome you to one more episode of our True ML Talks and would love for you to introduce yourself to our audience as well.
Sure. Thanks for having me. And to introduce myself, I'm Dennis. I lead the machine learning team here at Voiceflow. Been with Voiceflow for almost 2.5 years. I joined as the founding ML engineer, so figuring out what kind of ML applications we can apply to the company, developing the strategy, building out the team, and now we have several product lines in the machine learning space. Prior to that, I was working as a senior cloud architect for a global bank, working on data systems, ML ops, and some core infrastructure. So,
Nice. Awesome. Would love to dive a little bit deeper into your journey with machine learning. Like how did you get into machine learning? What got you excited about the space and what got you excited about joining a conversational AI startup as well?
yeah, so I guess I joined summer of 2021. At that point, GPT-3 had been out, but was still less used. So we hadn't hit the sort of generative AI wave that we had experienced. We hit sort of the first NLP, NLU wave with the transformer model, BERT, and a couple others coming out sort of 2017, 2018. So I thought it was a very interesting space to join. I was thinking about the different career opportunities available. I could sort of stay in core cloud infrastructure, scalable systems from a data perspective. But I thought machine learning is the future. The power of automation there is quite impressive, and that's only continued to grow. So I think this opportunity was not something that I specifically sought out after. I actually used to work with the CEO before, so it was one of those opportunities where I was looking and the timing aligned. So here I am today.
Nice. Awesome. How about the journey? Like when you started, you were the first one, like basically like in the machine learning. So you kind of kicked off the overall ML teams here at Voiceflow, is it?
Yeah,
Got it. So tell us a little bit more about the journey of kind of building out the initial few, what are some of the features that you worked initially? How did you go ahead and expand the team? Give us some more context on that. Yeah.
for sure. So I think when I joined, it was a question to figure out what's the best use case for building our own models versus using external models. So at the time, Voiceflow was using third-party NLP NLU engine for the core sort of chatbot experience. We're using text-to-speech and speech-to-text models, third-party ones. And it was a question of, do we sort of replace those right away, or does it make sense to build some machine learning features for some other aspects? So the first thing that I did is build a couple of proof of concepts, things that we can do, and they kind of went into two different buckets. So Voiceflow is a low code creation platform for conversational assistants. And it was a question of, do we improve the experience with automation on how to create those assistants, or do we find a way to actually improve the assistants themselves, right? So both of those were extremely valuable to our customers. So explored a couple of different options, built some simple proof of concepts. And once we got a couple of ideas that seemed to have traction, we built out the first customer facing version. So the first feature that we built was utterance generation. So for context, many chatbot platforms use a model where you have intents, which are like categories of user actions, and they have utterances, which is the examples.
Right.
So we can augment with machine learning, call it generative AI, right? The examples that a user needs to add, so they can enrich their own data model, right? So you're using machine learning to enrich another machine learning model, which is a lot more common now with more advanced generative models. So we had the POC built. We built sort of a simple front end, ran some user tests, ran a beta for it. got pretty positive feedback. Um, and while that was happening, in the background, we were building out our MLOps platform. So for that, the goal was to be able to deploy several of these experiments into production very quickly, as well as manage the environments. So this was a large problem that I'd seen sort of in my previous role, along with talking to other startups and companies, is that deploying first you have environment drift between dev and production, which was is a large issue. But you also the velocity of getting a model from sort of a POC model wait stage into production took a very long time. So sort of optimized on two of those factors, deployed the models or that utterance generation model into a production environment, and eventually that got integrated into the platform, sort of from a front end perspective. So it's pretty interesting because that model was the first to be killed by the release of ChatGPT um, because those generative models just were much better at generating very varied data. So that's something interesting. It's like the first model you build is the first one that gets killed off. It's kind of a funny story, but at the
Yeah,
end of the day, what matters is how do you impact the customer experience? What's the best use case, rather than being too fond of your own developments.
makes sense. Makes a ton of sense, and like especially in I guess in the space that you all are working in, conversational AI space, like there has been this massive shift because of the launch of these instruction tuned GPT based models, basically. Um, Going back to 2021, when you started, were you using GPT 3 like the or GPT 2 at that point when you just built out these models?
Yeah, so GPT-3, I think, was still API gated for beta. I mean, I knew about the model, but it was like sort of, it was slow, it was expensive, it was gated. It it didn't necessarily have, it wasn't top of mind for many people, especially because in the initial release, it was like, oh, this model is too dangerous to be used by the greater public kind of thing. So knew about it, didn't really think about it too much, which probably going back, that was a little bit of a strategic mistake. Um, but yeah, we weren't using it. We built our own sort of. We tried using a generative model. There's a couple that existed. Played around with BART, GPT-2. There's also sort of the Blender bot models that also existed for Facebook at the time, sort of to see what kind of answers were generated. But generative was still very slow, so we ended up building a fairly comprehensive just vector search. At the end of the day, it wasn't what we called it, but it was just a search index using face to have a large variety of utterances that were semi-relevant, because the hypothesis was that the utterances a user wants to select has a long tail, right? It has some very popular ones like a greeting or a goodbye or a yes or a no or all of those. Um, but some of the more domain specific ones users might not care about as much. And if they did, we can specifically focus on those like banking or healthcare or automotive or some of the other domains that our customers were in.
Got it. Okay. I think you bring up some very important points where I have like a bunch of follow-up questions. So, one is around the business itself, and you talked about different industries. I would love to understand if there are certain industries where voice flow caters more, and do you see any industry specific challenges? That's one thing. And after this, I would love to follow up a bit more on some of the challenges that you talked about, cross environment drift, and how you built out that initial part of the MLOps pipeline. So I would love to dive deeper into these two things with you.
Yeah, for sure. So for the industries, I think we cover a wide variety of industries. So on the enterprise side, we have 60 enterprise customers, ranging between retail, banking, automotive, utilities, government. Like it's quite a variety. So um, that makes it challenging, especially when we were building our NLU model, the actual model that powers the chatbots, to have the capability to cover all of those domains. So that was definitely a challenge. Right now, we're having quite a bit of growth in our smaller market segment. So we have four plans. We have a free plan. Anybody can sign up for Voiceflow and use it. We have a pro plan for individual creators, teams for smaller agencies or businesses, and then enterprise. So in that agency pro space, we've seen a lot of growth in industries like e-commerce and real estate. So those are actually interesting because they do diverge quite a bit from the enterprise base. So that does exist. It does make it a little harder to do that. I think we can chat about the NLU a little bit later because that's its own adventure.
Yeah.
Um, but moving on to the second question of the environment drift and data drift. So I think what's challenging there is that as data scientists, the goal is to get to an outcome as quickly as possible. And that's typically like a training notebook. And then after that, typically at most companies, you do a handoff between like a data scientist and a machine learning engineer or whatever the role might be, production, backend engineer. Every company has a slightly different name. Um, so for in that case, our goal was to stop that sort of handoff process from happening. So anybody who designs the model, trains the model, deploys the model. Now, to do that, the challenge is that now you've broadly expanded your stack, right? You've went from Jupyter notebooks, training jobs, PyTorch, fine tuning the model itself, and Kubernetes, like queuing system, like REST and response or gRPC or whatever protocols that you're using. And that is a different job, right? So what we did was that we created automated environment creation that would spin up. I don't even remember how many services we have in there now, probably like 15 different services in the cloud environment. Made it very easy to set up a new one if you needed to. And then it would deploy all the models automatically. We have a CLI called ML CLI. You would create the model, it would structure all the folders for you, create the Terraform that created the services. You then hit model deploy, you specify your environment, and that's it. Um, so we automated a lot of that MLOps portion of model deployment and observability because we included that as part of it, along with some security built-in considerations. And that allowed the engineers to not necessarily need to dig into some of the nitty-gritty things like which drivers to install or some other things. But sometimes bugs would pop up and you'd have to deep dive into that specific part of the code base. So quite a different philosophy. I suppose most companies that have specialists, the goal was to have an engineer own the model end to end, sort of from requirements to delivery to reduce that context switching.
Lovely. Like, there's something that I personally agree with so much to, and I guess like my personal influence is coming in from my time at Meta, where we used to have this saying that you build it, you own it.
Mhm.
And like that's a philosophy that you all are following at Voiceflow as well. So makes a ton of sense. And but obviously, it's a very hard feat to pull off because you want to build out a lot of this tooling that makes it easy to do the right things and like more difficult to do the wrong things. And the way you described the way you kind of ended up building this is you almost kind of ended up creating templates of these deployments for your data scientists, and that's kind of how they took things to production. But I also understand that whenever you have issues in such a setup, it can become quite a bit to debug because they don't have full visibility into the pipelines that have been built, right? So tell us some challenges that you ran into when you expose some of these templates to the data scientist, they were working with it, maybe what kind of specific challenges you ran into with this. Yeah.
Yeah, some of them were simple things like we use poetry for package management. Like you bump a version and it cascades stuff up,
Right.
or you add a new dependency, you have a conflict. Um, Things with copying, for example, we have a structure for where to put your model or where to put your files, right? And sometimes things don't get copied or downloaded, and it can cause an issue because some things, most things get for almost all models, things get packaged at the Docker container level, but because we often do a remote build, you need to make sure it's pulling from the right
Mhm.
repository. So for example, in your local environment, you might have the model there, but if you forget to upload it into the cloud storage, right, it's going to break. Um, Things like that. There's other issues with like concurrency sometimes, like we use a queuing system and sometimes we exploded memory requirements because the queue pulled in too many messages, right? And concurrently, it just blew up the GPU requirements. Um, things like that. We've had a few adventures with it. Things with caching, right? Blow up the cache accidentally sometimes. So I think the nice thing though was that we built all our models to be real time based. So we didn't have that sort of fork in the road of batch based models versus real time. Everything generally used the same architecture. So as long as you had messages going in and messages going out for inference, then it should work the same. Some had lower latency requirements, some had more leeway for that because they were bigger workloads, but largely it made it a more consistent system. And thankfully, we started with a real time paradigm and we didn't have to go through that whole migration or shift, which a lot of companies are going through now or trying to go through now.
I see. Okay. So you mean to say like most people focus on kind of batch inferencing more, and you're like initially from the beginning you ended up building out the real time inferencing pipeline basically.
Yeah.
Got it. Very very interesting. And you mentioned that even the batch you served using the same pipeline, is it?
Uh, we very rarely had true batching. It was still all real time based. It just had a longer latency. So
Got it. How about things like backfill and all? I assume that you would have had like some use cases for backfill and all, right? Like maybe system was down and you had to.
yeah, so for backfilling, we would just drop it into the queue, and then if the workers came up or we
I see.
scaled it back up, it would get fulfilled. Um, we did think about sort of a more complex architecture of having backfill for a couple of things, but we didn't end up building it just due to complexity and focusing on other problems. It's kind of the trade-off. Do you build a bunch of good models or you build a few great models? And it's actually really hard to tell what you need when you launch.
Right.
It's very challenging what users are okay with. So generally, we've erred on the side of launch a good model, see where you get feedback, see where you can optimize, because otherwise you get into this cycle of untime box models and
Exactly. Yeah.
you're not delivering any business value. So
Correct. Yeah. 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 Absolutely. And like this entire architecture, this is actually considered a fairly advanced architecture where where like at least we don't see most companies taking up this architecture, and it makes a ton of sense to us. Like we at True Foundry very commonly suggest this queuing based systems where send a bunch of requests to the queue and then arbitrarily scale like the like how you consume then process those requests basically. But then there are infra challenges that come with this as well. That how frequently are your pods able to come up? How frequently are you able to scale your system down? So what type of technologies do you end up using for that sort of auto scaling? And did you actually and it would also help for us to understand what kind of traffic pattern was there any uniqueness to the traffic pattern that you were seeing because of which that you could leverage in your auto scaling setup, I guess.
yeah, it's a great question. I think what's interesting. So on our enterprise business, there's a very clear traffic pattern. We're mainly in North America with some European presence as well. So you could see sort of when Europe wakes up, when East Coast wakes up, when West Coast wakes up, and then goes back down. What's actually interesting is that our built-in capacity for the models was so we deployed in a HA setup, so 2 or 3 pods with GPUs per model, and that actually was enough for us to handle any scale up and scale down, and it wasn't necessarily worthwhile to scale down to like one because then you run into some
Right.
weird issues with availability
Yeah.
or traffic spikes. So we just have a baseline there. We have if we anticipate workloads, we can spin up pods. That usually requires spinning up a new node pool. We have it set to auto scale with our Kubernetes deployment pattern, but that takes a couple of minutes. So if for some reason we get bombarded by training requests and we have no indication that we need to scale up, that's going to be a challenge. We did explore having more sensitive scale up and scale down. Like we were looking at, for example, Keta as an operator to see how many, if you have a certain number of messages in your queue, do you scale or up or scale down? But again, that introduces some complexity there. So for now, the base workload is fine. We have monitoring set up. If certain messages take longer, that somebody can take a look and see what the issue is. Because sometimes it might be a retry that doesn't get go into the dead letter fast enough. Sometimes it's a traffic spike that we didn't anticipate. Sometimes it's another issue. So um, we don't have too much auto scaling enabled at this point because generally traffic patterns fit within our requirements.
Got it. Understood. Makes sense. And which cloud provider do you end up using? AWS?
Combination of AWS and GCP. As a company, we're multi-cloud because our enterprise customers have different requirements.
Got it.
So for that, the ML stack is deployed across multiple places.
Got it. Got it. Got it. And so on that note, do you kind of end up using like Carpenter or Autopilot as well? Have you explored those GKE, Autopilot, and stuff?
Uh, we haven't. I think Autopilot was really coming out when we've already built out the infrastructure.
Got it.
So again, it's a trade-off of engineering time. There's other things like, for example, we mainly use T4 GPUs for a lot of our workloads. They're
Okay.
quite optimal for that. But Google, for example, recently released L4 GPUs, but
Hmm.
they require migration on NVIDIA driver versions, on PyTorch versions, like all these different things that from an engineering perspective take a long time, and we time boxed the migration. It didn't work, so we left it for now, as an example.
Understood.
So all these different things that I think as a startup, it's right now engineering time is most precious. As we continue to scale up, eventually infrastructure costs catch up.
Makes sense. Nice. And this you had also talked about the real time system and some of them being latency sensitive as well. I'm very curious that for latency latency sensitive models specifically, did you end up exploring any interesting model servers and ran any experiments or it chose one specific model server and that worked out fine for you? Love to hear about your experiments on that.
Yeah, so we tried out things like torch serve. We're using PyTorch, but the challenge is that they can be quite opinionated and fairly complex to run. And again, at our scale, having a model per GPU or a couple of GPUs per model worked out fine. So we went with a simpler approach. Our inference is also quite generic. So if we, for example, wanted to switch to Keras or raw TensorFlow, right, we could. There's nothing that requires us to stick with PyTorch, which is kind of nice. And at the end of the day, the models that we're using, they're small enough where the model latency isn't the main driver of latency. It's either network traffic or post processing that you have to do. So it's a little bit of a more unique case where it's not like we're trying to serve Llama or something else as of
Right.
now. Um, in the future, that would change, right? Open source models, the bigger ones, and are getting better for specific use cases. But in our use case, we use mainly sort of encoder models, and those are small enough that the model latency itself isn't as big of a factor.
Got it. Understood. Makes sense. And is that world changing with the new wave of generative AI? Like, are you also experimenting with other open source models like Llama or Falcon and stuff, or are you using OpenAI? What's happening on that end? Yeah.
Yeah, so within Voiceflow, you can choose different models to use. You have the OpenAI models, you have the Anthropic models. The challenge with open source right now is that it's moving so quickly. The optimizations are moving so quickly that we've sort of made the decision to wait it out and see. From a cost perspective and a customer requirements perspective, those two set of models cover most use cases. We've also been looking into some of the Palm models, or there's the Bedrock models as well that have recently come out too, Cohere's models as well. So for all these different models, there's a lot of variance, and until we hit the scale where it makes sense to run Llama or something else, then we'll look into it. I think that that time is coming up soon. But even if you, let's say we get Llama 2 deployed and Llama 3 comes out, right, then you're sort of back to the drawing board for that as well, in a lot of ways. So we the open source scene is very exciting for that reason, but at some point, something will flatline. If Llama 3 comes out with a 30 billion parameter option, right, that'll probably be that time where it's good enough to say, okay, we can host our own LLM.
Got it. I see. Very interesting. And like with like the GPTs of the world, did you feel like you had to go like the route of fine tuning the model, or like like just zero shot or few shot learning was sufficient for you?
Yeah, we tried fine tuning. The fine tuning on the ChatGPT models only recently came out. Before that, they're much smaller. The
Right.
smaller models did not work as well. Few shot learning was a better choice. And at the end of the day, we let our customers choose. So there's the models that exist. They can connect to their own models via our API integrations as well. So there's a lot of customizability in the platform and extendability there. But playing around with the fine-tuned ChatGPT, it's not that much cheaper than GPT-4 actually, which is kind of
Right.
funny, right? So um, you run into some challenges there, and then it's the whole thing about okay, you get new training data, you retrain, like the base models change themselves as well. So fine-tuning does introduce some challenges too.
Got it. So in your experience, directly using GPT-4 turned out to be better than fine tuning a GPT 3.5, for example.
Yeah.
Got it. Very nice. And also like the sentiment makes sense. Like because once you have fine tuned it, it's like your own specific model. Like there are other challenges that come with it, whereas GPT-4 can like net scale much better across different use cases. So I assume it's also easier to manage and maintain overall that way.
Yeah, you don't have to worry about those versions, fine-tuned versions necessarily. I mean, even vanilla ChatGPT is very good for many applications. So.
Got it. But like this is very interesting because I think you mentioned some of the models that you were using were such that like even the model latency wasn't even the primary factor. Like the network latency and all were like the most important factors. But I assume like that's out of the door, like completely out of the window when you start using GPT-4, right? Because
Yeah.
the latency would be like orders of magnitude higher than that, I assume. So how are you handling that?
Yeah, so I think this is where giving users the choice and the education on what to use. So we do have guidelines for using the different types of models. We released education material on that. If somebody needs higher precision right on their task, better formatting, less hallucination, whatever it might be, then GPT-4 usually is a better choice. If latency is a bigger concern, like for example with our knowledge-based product, which is a RAG-based solution, we use ChatGPT or Claude Instance for the summarization portion of that, because in that case, the user latency is more important. And if latency is the most important one, then we recommend that you use sort of an NLU-based approach with intense utterances and static responses, because that's going to be the fastest thing that you can deploy.
I see. Understood. Okay. So like you kind of handle that problem by giving that choice to the end customer, basically, that which model that they want to end up using. Okay, understood.
Yeah.
And for the retrieval augmented generation type of system that you're building, like what sort of like stack that you end up building, like what sort of embedding models, what sort of vector databases, and like would again love to hear if you ended up running some experiments to choose those.
Yeah, so a lot of it has to do with cost and time to build. So, for example, we're using text embedding data because it's multilingual, it's fast, it's cheap. There are other models available that we looked into, but the delta isn't there. For example, to use something else like GTE or E5 or something else that's open source. So because you have to run it yourself or integrate with Hugging Face or another provider still. Um, so that makes it more straightforward. For vector databases, chunking strategies, all that stuff, we've built a test suite that we've been using internally. So we would set up different strategies for chunk parsing for different data types, whether it's websites or PDFs or text files. Um, we compile that both with our own internal tests or when customer complains and says, "Hey, this broke. Why is this the case?" and try to generalize that either with the prompts or the retrieval side of things. It's a challenging problem because going back to your question about domains, everybody's domain is a little different. Everybody's use case is a little bit different. So we try to group them into categories. And eventually the goal is to give the power to the user to test their own prompts, test their own processing and chunking strategies, because they know their data the best, right? We can only infer if you put certain information into the knowledge base what you want to get back. But at the end of the day, the user knows best and can evaluate that.
I see. Understood. Um, hmm. Makes sense. One other area that I would love to understand, and this is like you're in this unique position where you had built out a lot of NLP based solutions earlier, and now you're kind of transitioning. I can see that slowly different components to the I guess the latest and greatest models, basically, right? Like both for embeddings, your large language models, etc. What are some of the challenges that you are facing from an engineering standpoint, from a product standpoint, when you're doing this migration? Like this, like one set of companies, for them it's like they invoke an API endpoint, and it's like a completely new solution. So like I feel like they are solving a much different problem than the companies who had some quote unquote legacy solutions built out in this domain. So I'm very curious to hear your experience on that.
Yeah. So I think what's interesting here is that even our legacy solution. So the utterance recommendation model I mentioned before, that was clearly replaced. That's fine. Other things like our NLU model, it works better than the generative models as of now. It's kind of the paradigm of fine tune a smaller model for your task, and it'll generally work better. It's faster, it's cheaper. We've done some experiments on that, published some results. So that's something that's interesting. But generally, I think it's like even the whole concept of prompting, right? It's still fairly ambiguous. It's challenging. A couple of papers that have come out that do sort of self-learning on some of those things, but that takes a lot of time and resources to do that. So again, it's that balance of, do you have a good product, do you have a great product, do you have the best product on the market, kind of thing. So that's kind of from a product perspective. From a infrastructure perspective, one of the nice things was that integrating those models was quite easy because we had sort of that modular architecture. We have a service called ML Gateway that we use to serve these different models. So regardless of if it's a general third party API, if it's our own APIs, it all goes through there. So you just add it kind of as a provider and off you go, right? The front end now knows what to call, and it's not too hard. So I think that's where some of those architecture decisions have had that impact of letting us move and adopt and use those models. But even then, it gets a little bit challenging. Like if we add another LLM provider, for example, how do you deal with those prompts, the few shot learning, the few shot examples? How do you sort of communicate that to users? How do you price things, right? It all gets very interesting. So we've opted for a model where we find the minimum that we need for things to work, and then until customers are banging down our doors to say we need this, we stick for our initial plan. So
Got it. Understood. And talking about cost, do you pass along your cost, like the OpenAI cost, to your customers, or is that baked into your product?
yeah, so we have a combination of that. So for certain models, we require you to be on the pro tier or higher. So for pro, you can't until you have pro, you can't access GPT-4 or Claude. Um, for for that, there's kind of a baked-in example. We give users sort of a set number of tokens as part of their subscription. So free, you get like 100,000 tokens. Pro, you get 2 million, and so forth along that. If users want to buy additional tokens, we also have that capability because we want everybody's using us in a slightly different way. So some people we consistently say they're using AI functionality, so Gen AI, OpenAI's models. So they're more focused on that. So we don't necessarily want to sort of raise prices or increase the number of tokens when that's not what people are using us for. So we have that flexibility, but we're still listening to customers to figure out what's the sweet spot there.
Understood. Makes sense. And one, especially like, given that you're kind of in a B2B space, like helping other companies in different verticals as well. Um, I have been hearing a lot of news around, like, like a lot of our customers are kind of concerned about the data privacy, like sending it to OpenAI, especially if it's like, you are a vendor who is dealing with customers' data and stuff. So, how is that equation playing out for you all? Like, are you using Azure OpenAI? Do you have any other discussions with your customers about this? Would love to hear that as well.
Yeah, so we are using Azure OpenAI for that, also for latency reduction and such. One of the things that we do offer for enterprise, so we offer private cloud deployments, which is a virtual private cloud. You get full isolation with your application and data stack, and with that, you also have the ability to configure some of your own endpoints. So we have a bring your own LLM model. So if you have your own Azure OpenAI model or endpoint that's gone through your security requirements, it's approved. You just swap it in, put your secrets in a secret vault, right? Point towards the
Hmm.
right domain, and off you go. You have your own custom voice flow using your own LLM. So we are very cognizant of that. We've had quite a bit of interest from that perspective. So we do completely understand where companies are coming from.
Got it. So, like, deploying on a customer's cloud, I understand that part. Like, everything else remains in their own cloud. But like, if you're invoking the OpenAI APIs, that data would regardless go out of their VPC, right?
Yeah, but they can customize that. So if they point it to their own Azure OpenAI instance,
Oh, I see. Okay.
we assume that they've already done whether it's a security review or a contractual review or whatnot, and they can control that. Some customers have said no Gen AI, so we just flip the switch, and there's no Gen AI on their product.
Got it. Understood. I see. Got it. Okay. Hmm. Makes sense. Okay. So that part is handled again, like, kind of like the customer gets to decide what models do they want to bring in, and stuff. And on that note, like, would you also allow a customer to bring in, let's say, one of their kind of quote unquote custom models where, like, let's say they have, let's say, fine tuned a Llama 2 and they wanted to use that. Would that be allowed as well?
Yeah, that we handle on a case by case basis, just because things are different, right? Even the prompt engineering between ChatGPT and Llama 2 is quite different. With Claude, it's different. The
Right.
APIs are structured in different ways. The way you measure token consumption is different, right? So that's more of a case by case basis. Obviously, for larger customers, that's definitely an option. We want to provide the best experience. But for a smaller customer, we're like, well, we're not going to do that for you, right? We have enough extensibility. If you want
Right.
to use your own custom model, here's the API step. Go crazy, right? So I
Makes
think
sense.
that's setting reasonable expectations. But if you're a flagship customer, then we're definitely having those conversations.
I get it. Makes a ton of sense. And I think that's most of the question that I had. And, like, this is super enlightening about how you kind of like literally got started from a clean slate to, like, now you're navigating the team and the company to work with the new generative AI wave. Maybe, like, just one thing before we drop off, like, are the newer advancements, like, do you deal primarily with text data, or you feel like the newer advancement with the visual data, etc., will also be utilized at Voiceflow? Like, any plans with that?
Yeah, I think multimodal is super interesting. It's kind of a discussion we have every day, right? Because we're reading the papers that are coming out. We're looking at what models are available. We're looking at some of the paradigms, right? Even things like synthetic voices or cloned voices. It's super interesting, but it does add a lot of complexity to the product. And that's kind of we're in a lucky position because we have a cross section of customers. We have some of those free tier or pro builders who are just trying to build the coolest thing, and we can see what they want, what kind of features they're thinking about. We also have enterprise, which is a little bit more conservative, right? Focused on more traditional use cases. So we're definitely thinking about that, but it does provide some challenges to a system, right? So, for example, if you add images or sound or something else to some kind of retrieval system, now you have to use the multimodal embedding system. And for example, Facebook has done quite a bit of research into that space. Um, but that embedding model is no longer available as an API, right? So now do you migrate everything over? Do you have separate like search indexes for that? Do you do some kind of translation? Right? These are all technical decisions that spawn from that business one. And it's kind of it's an unknown, right? How many people actually want to interact with an image, right? We have
Yes,
some ideas, we have hypotheses, we're planning according to that, but it's hard to know before you actually launch. So um, definitely interested in that, but it's such a novel and interesting space that I think very few people have the answer.
makes sense. I understand. Well, awesome. Thank you so much, Denise, for taking the time and speaking with us and sharing your experience of building, machine learning teams, NLU based solutions, conversational AI based solutions, ground up, and navigating the company through this new wave. Really appreciate this. Uh, Thank you so much.
Yeah, thanks for having me, Nikunj, and thanks everybody for listening.